Hi, welcome back to Physics Teacher. This is question 24 of 25 on the Pascal contest in year 2021. It's a grade 9 math contest from Waterloo University. Give it a try and I'll be right back with the solution. Alright, so let me break down this problem for you. We have a deck with cards 1 to 66. And then we perform a shuffle. Now in this deck, the cards start off in this order, 1, 2, 3, 4, and so on, all the way up to 66. And the shuffle takes the first half of this list, so 1, 2, and so on, all the way up to 33, that would be the first half, and changes their position into every odd position. So for example, 1, well, that would stay as 1. But the number 2 would change to the 3rd position. And the number 3 would change to the 5th position, and so on, getting all the odd positions. However, the second half of the deck, so 34, 35, and so on, all the way up to 66, they end up in all the even positions. So 34 becomes the second card in the deck, 35 becomes the 4th card in the deck, and so on. And then we do 1,000 shuffles, just like this. And the question says, how many times in these 1,001 decks does the number 47 appear in the 24th position? Alright, so let's label a position in the deck as X. So we'll call position X. So if you're in the first half of the deck, that means your value for X is somewhere between 1 and 33. And if you're in the second half of the deck, 3, you're somewhere between 34 and 66. Now notice if you are in that first half, you can look at this as your position, your shuffle changing to 2x minus 1. Let's test that. Let's say originally you're here in your second position. You end up moving to the 3rd position. So try it. 2 times 2. So 2 times your position 2, which is 4, minus 1 becomes 3. Right? Or if you're originally in the 3rd position, well, 2 times 3 is 6, minus 1 is 5. So this tells you the shuffle of your new position if you're in that first half. If you're in the second half, so if you're 34, you end up in position 2. So first let's take that number 34, X, that's your position, and minus 33. Let's go back to the sort of the beginning. And so that'll put it into the first position, and then we multiply by 2. You can check this works with the other ones as well. 35, well, subtract 33, and that's 2. Multiply by 2, and it's 4. So these are the operations we're going to use, whether or not we're in the first half of the deck or the second half of the deck, to determine our new position. Now, let's look at all of our decks. So we're going to make a chart. This is going to be our deck, and this is going to be the position. Now we're not going to do this for every single card. We're only going to do this for number 47, because that's the one we're interested in. When is it going to be in the 24th position? Well, in our first deck, that's easy, it's in the 47th position. And the 47th position is in the second half of the deck. So in our second deck then, we're just going to apply this operation where we'll do 2 times 47 minus 33. And that'll equal 28. Alright, so our original 47 is now in our 28th position. Well, let's see what happens in the third deck. So now it's in the first half, so we're going to apply this operation. So 2 times 28 subtract 1. And that gives us 55. And we're just going to keep going, applying these whether or not it's in the first half or the second half. We're not going to do this 1,000 times, but let's just keep going to see if a pattern emerges. Alright, so we'll stop there, because you'll notice we started in position 47, and now after 12 shuffles, we end up right back in position 47. Which means this whole process, these 12 shuffles, are just going to repeat and repeat and repeat. And in these 12 shuffles, how many times did we end up in position 24? Well, right here, once. So after 12 shuffles, we end up in position 24. Alright, so what about after 1,000 shuffles? Well, 12 shuffles can go into 1,000 83 times. So if we perform 12 shuffles 83 times, that's a total of 996 shuffles. There would still be 4 more after that, but you can see in the next 4, we don't reach 24. So we do this whole rotation of 12 shuffles 83 times in 1,000 shuffles. That means we end up in position 24 83 times, or our answer is C.